The database management system can interleave transactions to enhance performance. Or we saw that we might get different results if we change the order of transactions or order of set of instructions within different transactions, which is what happens when we interleave transactions. So, what do we do not to let that happen? Does that have anything to do regarding isolation and consistency? The answer is yes. The isolation property is ensured by guaranteeing that even with interleaving, the effect of executing transactions is identical to executing transactions in some serial order. To explore that, we have to learn about serial and serializable schedules. Scheduling is a regulation of transactions in a relational database management system. As transactions arrive at the database management system and request reads and writes of the database elements, these requests are passed to the scheduler. Scheduler provides the schedule, which is a sequence of important actions like read or write, followed by a commit if the transaction is successful, or an abort if not, which are taken by one or more transactions. A schedule is a serial schedule if actions of different transactions in it are executed from start to finish, one by one, and it does not interleave the actions of different transactions. Interleaving is a change in scheduling, and we saw that changes the effect of transactions on the database. A serializable schedule is a schedule that is equivalent to some serial schedule. What does equivalent mean, though? Two schedules are equivalent if, for any database state, the effect of executing them on the database is identical. So, let's remember the examples 1, 2, 3 that we had. The schedules in example 1 and example 2 were serial, and the schedule in example 3 was serializable because its effects on the system was identical to executing the schedule in example 1, which was a serial schedule. The question here is, why all interleaved transactions cannot preserve isolation? This is because different types of anomalies that break isolation and serializability can happen. These anomalies may happen because of or with certain conflicts between interleaved transactions. This does not mean that conflicts always result in anomalies. We may still have conflicts that happen without causing any anomalies. But what is a conflict? And what do we need to check to ensure that conflicts are not happening? Two actions conflict if they have the following 3 conditions. First, they are part of different transactions. Second, they involve the same variable. And third, at least one of them is a write action. Let's see an example. We have transactions T1 and T2. Transaction T1 has read A and write A. Then read B and write B. And if we consider the y-axis as time, increasing when we move down in our column, they happen in time in the shown order. Transaction T2 also has all the same actions. Based on the timing of transactions, we have interleaving. Means read A and write A from T1 happen, then read A and write A from T2, then read B and write B from T1, and finally read B and write B from T2. Based on the definition of conflict, what are the conflicts in this example? Following the definition, let's mark them with arrows. They need to be from different transactions. So, between those of T1 and T2. They need to be on the same variable. So, those of either A or B. They need to have at least one write. So, they should be write-write, read-write, or write-read combinations. We mark them with arrows. Read-write ones with yellow, write-read ones with blue, and write-write ones with pink. Let's quickly review before moving forward. Two actions conflict if they are part of different transactions, involve the same variable, and at least one of them is a write. And based on the fact that we have read and write actions, needing to have at least one write in the combination gives us three types of conflicts: read-write, write-read, and write-write. So, what is the significance of these different types of conflicts, and what anomalies can happen by them?